Welcome back. Coming to the online course Module 3. In Module 3 we will be discussing regarding cement. Cement, it's a material which possesses adhesive and cohesive properties capable of binding materials like bricks, stones, building blocks, etc. Classification of cement. Cement is being classified into four types: natural cement, pozzolanic cement, slag cement, Portland cement. Natural cement. It is being prepared by calcining a naturally occurring argillaneous limestone at very high temperatures and pulverizing the calcined mass. Calcium silicates and aluminates are formed by the combination of silica and alumina with calcium oxide during calcination. Properties. The properties of the natural cement are: it possesses hydraulic properties, it is quick setting cement, it possesses relatively low strength. You can see the different uses of hydraulic cement. It's used for chimneys, drainage system, swimming pool, foundations, basement walls, manholes. Applications. It is being used in laying bricks and setting stones, and it is used in large masses of concrete such as dams and foundations. Here is a pictorial representation of the different uses of the hydraulic cement. Pozzolanic cement. It is the oldest cement which has been invented by the Romans. And the preparation of this, it is made by mixing and grinding of natural pozzolana with the slaked lime. Natural pozzolana is a deposit of volcanic ash which is produced by the rapid cooling of lava, which we can see in the figure. Lava in turn is a molten mixture of silicates of aluminium, calcium and iron. Properties of the pozzolanic cement. It also possesses hydraulic properties. Applications: they are mixed with Portland cement and then they are being used for different applications. Slag cement. It is made from the hydrated lime and blast furnace slag. A mixture of calcium and aluminium silicate is granulated by pouring it into a stream of cold water. It is dried and mixed with hydrated lime. The mixture is pulverized to fine powder, and accelerators like clay, salt or caustic soda are added to the hasten hardening process. Slag cement is having little slow hardening process. So in order to increase its hardening process, accelerators like clay, salt and caustic soda are being added. Properties. Slag cement is generally a slow setting cement because they are poor in abrasion resistance, and slag cement is also having low strength. It is being used for concrete in bulk constructions. Generally in bulk construction, slag cement is being used. Portland cement. It is made by calcining at about 1500 degrees centigrade and proportional mixture of clay and lime containing raw materials. After calcination, retarder like gypsum is being added because this Portland process is going to set up fastly. In order to reduce its setting, we are adding a retarder like gypsum. Manufacture of the Portland cement. The raw materials that are required for the Portland cement are the lime component, the silica component, the aluminium and the iron component. The lime component, the sources of the lime component are the aragonite or the calcite or marl, shale and limestone. All these are rich in calcium. The silica component. Silica component we call it as a siliceous material which is being seen in clay, marl, sand and shale. The alumina component is the argillaceous material, clay, fly ash and shale. Manufacturing process. The manufacturing of the Portland cement involves four stages: crushing, mixing, burning and grinding. The pictorial representation, the clay and the limestone are being mixed up in the raw mill and then they are being moving each step. All this we will be discussing individually. One is the crushing. It is done in a primary crusher. The limestone and the other materials are being taken and they are being put in a crusher and are being crushed and finally converted into powder. We have two types of crusher, the primary as a crusher and a secondary crusher. In primary crusher the size will be reduced to 5 inches and in secondary crusher the size will be reduced to 3 to 4 inches. Mixing. It begins with the acquisition of raw materials such as limestone, sand and clay. They are mixed. The three ingredients can be mixed either by a dry process or by a wet process, and these raw materials are being stored in bins. and then sent to the grinding mill. The dry process produces a fine ground powder and it is stored in bins, and the wet process in presence of water results in a slurry which is mixed and pumped into the storage bins. What is the difference between a dry process and a wet process? Dry process is little slow and costly, but comparatively wet process is faster and cheaper. The cost of production is less and fuel consumption will be low in case of dry process, and the cost of production is higher because of fuel consumption is higher. And shorter kiln is used in dry process, longer kiln is needed to drive off excess of water. There is more water in case of wet process, so a longer kiln is required, which is not required in case of dry process because the quantity of the water is less. Kiln is generally like a heater which is going to remove off the water. The quality of the cement produced is inferior in case of dry process, and the quality of the cement produced is superior and most accurate of composition can be attained. This process is adopted when raw materials are quite hard. Dry process is been adopted when the raw materials are quite hard, and wet process it is preferred when the raw materials are soft. Dry process is not suitable when the principal raw material has inherent moisture content of 15%, and the wet process is being adopted in that case. When there is an excessive moisture in the ingredients, wet process is being adopted. Burning. Both dry and wet process feed is being put into rotary kilns where burning results into chemical changes. So the rotary kiln is nothing but a long steel cylinder with a length of 30 to 160 meters and diameters 2 to 4. The picture of the rotary kiln I will be showing in the next slide. Its inside surface is lined with a fire brick refractory. It is slightly inclined downwards towards the exitant. It can be rotated at desired speed and it is mounted on the rollers. The material is fed in the rotary kiln from the upper end. As the kiln rotates, the material passes slowly down from the upper end to the lower end at a rate controlled by a speed of rotation of the kiln. All those points can be seen in the picture that is being kept under it. The kiln is heated using solid, liquid or gaseous fuel from the lower end. The upper end is cooler. As the material passes through the kiln, its temperature is being raised to a point of clinkering temperature where the actual chemical reaction takes place. There are different zones: drying zone, calcination zone and burning zone. Here is the kiln. All the above discussed points can be observed here. The cooling area, drying zone. Here the temperature is moderate. The temperature will be maintained around 100 to 500 degrees centigrade and it is generally located at the upper end of the length of the kiln. This zone is called as a drying zone because the moisture is driven out and the materials gets heated. Here will be the drying zone. Calcination zone. Its temperature is about 1000 degrees and it is in the middle part. In this zone, the CO2 is expelled. In the first part, only the water is being removed and the temperature is maintained around 100 to 500. But in this calcination zone, the CO2 that is present is being removed and the temperature maintained here is 1000 degrees. Burning zone. Its temperature is about 1400 to 1500 degrees centigrade. It is generally at the bottom and the hottest portion of the kiln. In this zone, mixture melts and forms a little rounded mass of about size of peas, which are called clinkers. The clinker produced is a greenish black or black in color, and in this zone, lime and clay undergo fusion, yielding calcium aluminates and silicates. These are the reactions that will be undergoing. Grinding. From clinker storage, the material is transported to final grounding, where it is a requisite fineness is acquired. The finely ground clinker sets very fast by absorption of moisture from the atmosphere. To control the setting time of Portland cement, when it is mixed with water, 2 to 3% of gypsum is added. As I already told you, Portland cement is going to harden very fastly. So in order to slow down its setting time, 2 to 3% of gypsum is being added, which is going to act as a retarder. The mixture of the clinker and the gypsum powder is known as Portland cement. Together we are calling it as Portland cement. And this is generally the flow diagram that's going to happen in the wet process and the dry process. You can just observe it. All these steps we have already discussed. Limestone, clay and water. We have been doing a preliminary crushers and then to storage tanks, clay also. And both of these are mixed up in a grinding mill and then a slurry is prepared, rotary kiln, and finally weighing and packing. This is the overall process. So well, thank you. We will continue in the next module with the ingredients and their role, settings of cement, quick setting, what are the various factors that are affecting, and the uses. Okay, thank you.